Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about basics of graph. So when it comes to the basic introduction, so what is a graph here? So graph is nothing but a pair of vertices and edges, where V should be a set of vertices and A should be a set of edges. An element of the set E is generally denoted as edge. E is equal to U comma V or V comma U, where in the case of directed graph, so in the case of undirected graph. And here V is equal to a set of vertices in the graph, and E is the set, nothing but set of edges of the graph. So here what I'm going to say is, so graph is nothing but a pair of vertices and edges, and here V should be the set of vertices and E should be the set of edges, and E should be the edge that is going to represent it as VU and then UV as well. So in the given graph G, so if V is the set of vertices and E is the set of edges, then I am able to consider the edges here like this. So the basic terminology is that, so whenever I'm going to consider the two vertices V1 and V2 in the graph are said to be adjacent to each other. So if and only if they are going to be the end vertices of the same edge. So instance is that, so if the vertex U is the end vertex of edge E, then I can able to say the edge is to be incident on vertex U. So here should be the sum of the adjacent pair of vertices. So V1 and V2 are adjacent, and V2 and V3 are adjacent, V2, V4 are adjacent, and V3 and V4 are going to be adjacent. So whenever I can able to say that two vertices are going to be adjacent, so if the vertex U is the end vertex and edge of E, then the edge E is said to be an incident on the vertex U. And how can able to say this should be the adjacent here two vertices? So whenever the edge is going to be connect the two vertices here, then I can able to say that the two vertices are said to be adjacent. And special edges, like we're going to have some parallel edges and then loops as well. So if I'm going in between the pair of vertices, if I'm going to have two or more edges, then I can able to say these edges are said to be parallel edges. Similarly, if the both endpoints of the edges are same, then I can able to say this edge is called a loop here. So in between the pair of vertices, so if I'm going to have two or more one edges, I can able to say these edges should be is said to be parallel edges or multiple edges. And loop is nothing but, so whenever the edge is going to be start and end with the same vertex, then I can able to say that edge should be as loop here. And next one is the degree of the vertex. So if the degree of vertex V is denoted by degree of V, and that should be the number of edges incident on V. So the degree of vertex A should be denoted as degree of A, that should be 4, and degree of vertex B should be 3, and degree of vertex C is equal to 4, and degree of vertex D is 6. That means the number of edges that are connected to the vertex is said to be the degree of the vertex here. So if I'm going to select C, so how many edges are connected? 1, 2, 3, 4. So that's why the degree of C is equal to 4. So if I'm going to consider this, and how many edges that are connected? 1, 2, 3, 4, and 5. So that's why the degree of vertex D is 6 here. So like this, we can able to consider the degree of the vertex also. The next one is that pendant vertex. So what is a pendant vertex? A vertex with degree 1 is called a pendant vertex, and degree of V equal to 1. So whenever the vertex with degree 0 is called isolated vertex. So that should be degree of V equal to 0. So the vertex whose degree is 1 is one able to call it as a pendant vertex. And a vertex whose degree should be 0 is called as a isolated vertex. So what should be the edge set of this and vertex set of this graph? So the edge set of this graph should be UVW, edge set should be this one, and the degree of U should be 2 and degree of V should be 1. Here the W and V are said to be pendant vertex, so because whose degree is 1, whose degree is 1, so and the degree of vertex K equal to 0 here. And degree of the graph, so degree of graph is nothing but the sum of the degrees of all the vertices in the graph is called degree of the graph. Okay, so the degree of the graph is nothing but, so the sum of the degrees of all the vertices in the graph is called degree of the graph. So the degree of the graph should be denoted as d of g, that should be degree of the graph. And here what I'm going to say, so what should be the degree of 1? So 1, 2, 3, 5. And degree of V3, so 1, 2, 3. And degree of V2, so 1, 2, 3, 4, and one incident also is there, 5. So like this we can able to calculate the degrees of the graph. So finally I can able how can able to calculate the degree of the graph here. So once I can able to add up all the degrees of the each individual of the vertex of the graph, I can able to get what should be the degree of the graph. So normally how many edges are going to be there in the graph with 10 vertices and each of the degree 6. So for this the solution is that, so if a graph is going to have 10 vertices with each of the degree 6, then I can able to say the degree of the graph is equal to 10 into 6. And each edge is going to give the 2 degree. So therefore the total number of edges in the graph should be 60 divided by 2, that should be 30. So the graph is going to have 30 edges. So how many edges are there in the graph means, so if a graph is going to have the 10 vertices of a degree 6, so then the degree of the graph should be 10 into 6. That means each edge is going to have 2 degree. So the total number of edges in the graph if I want to find, then I can able to divide that by 2 so that I can able to get the total number of edges. So handshaking lemma, so that means the statement is that the sum of the degree of all vertices in the graph will always be an even number. Okay, so the sum of the degrees of all the vertices in the graph should always be an even number. So how this one is going to be defined is summation of degree of b is equal to 2 comma e. Suppose if I'm going to have a vertex, so what should be the degree of this? So degree of 1, 1, so 1 plus 1 how much? 2. So similarly, if I'm going to consider graph like this, so what is the degree here? 1, 1, 2. So like this should be the handshaking lemma, where A should be the number of edges. Does there exist a party of 11 proposals such that one has exactly 7 friends in themselves? So how can I able to find it? So if I'm going to translate the given situation of the party diagram by taking each person as a vertex, and their friendship is going to be shared by edges. So when we get able to get a graph G on 11 vertices, then the degree of each vertex is 7. What should be the this? So the degree of the graph should be 11. So if I'm going to consider 11 professors like this, and each professor exactly have 7 friends among themselves like this, and so what should be the degree of the graph? So the degree of the graph can be obtained by multiplying 11 into 7. And another problem is that, so how many edges are there in the group with 8 vertices and each of the suppose if I'm going to have uh, suppose if I'm going to have there are 8 vertices of degree 5 in the given graph, then the total degree of such vertices, 8 vertices, is equal to the summation of that. So 8 into 5 is equal to 40. And so if there are 8 vertices in the graph, like this, and the degree of graph is 5, then the total degree of 8 such vertices should be 8 into 5, that should be 4. So by handshaking lemma, so the summation of degree of the graph should be 2 into a. So what should be this degree already is given, so total number of edges equal to 2 into 5, 2 into e, then e is equal to 40 divided by 2, that should be 20. What are the other kind of special graphs here? So the graph without loops and parallel edges is said to be a simple graph, and a graph with n vertices without edges and uh, is called a null graph. A null graph with n vertices. So simple graph is the graph, a graph which should not have any kind of loops and then parallel edges. I can able to say that should be a simple graph. So whenever I'm going to have multiple edges, then I can able to say that should be a or should not be a simple graph. Null graph is the graph with n vertices without going to have any kind of edges between them. So this should be the example of simple graph and non-simple graph. So draw a possible graph with 3 vertices. So if I'm going to have 3 vertices, what are the possible vertices? So graph with 0 edges and graph with 1 edge will be, these are the possibilities, and the graph with 2 edges means these are the possibilities. So with the 3 dots, I can able to construct different kinds of graph. So based on the edges here, if I'm going to have only 1 edge, so what are the possibilities of the graph? And if I'm going to have 2 edges, what are the possibilities of the graph? So a graph with 3 edges should be like this. And types of graphs. So if I'm going to have different types of graph like multigraph and then pseudograph. So what is this multigraph here? So multigraph means whenever I'm going to have between the pair of vertices, if I'm going to have the multiple edges in between them, then I can able to say that should be the multigraph here. So whenever I'm going to have the multiple edges in between the pair of vertices, then I can able to say this should be the multigraph. Okay. So similarly, pseudograph means so whenever the graph is contain the loops as well as the parallel edges, then I can able to say that should be the pseudograph. Okay. So whenever the graph is going to maintain both the self loops and then parallel edges, then I can able to say this should be the pseudograph. So these are the some of the basic terminologies, basics of the graph. So what I discussed in this video. So in this one, what is the graph here? So graph is nothing but set of pair of vertices, and the edges is nothing but the 2 vertices are going to be adjacent whenever those vertices are going to be joined by the edge, and parallel edges. That means if I'm going to have the 2 or more edges in between the pair of vertices, then I can able to say this should be the parallel edge. And then loop is nothing but whenever the edge is going to start with an vertex and ends with also the same vertex, then I can able to say that should be the loop here. And degree of the vertex means it should be denoted by d of v. So v should be the number of edges that are incident on the vertex should be treated as a degree of the vertex. And pendant vertex means that a vertex with degrees is 0, what we call it as a isolated vertex, and similarly the vertex with degrees 1 is called pendant vertex. So the degree of the graph is nothing but the summation of the degrees of all the vertices in the graph. So if I'm going to consider a degree of the graph now, so first of all I have to find what are the vertices here, and then have to find the degree of all the vertices in the graph. Then have to make the summation of all the degrees of the vertices, then I can able to get the degree of the graph. So how many edges are there in the graph with 10 vertices and each degree 6 means that should be multiplied by 10 into 6. And according to the handshaking lemma, so the summation of degree of vertices should be the 2 into e here. So these are some of the problems what I explained, and these are some other different types of graphs what I'm going to have. Like a graph with a say without loops and parallel edges is called a simple graph, and a graph with n vertices without edges is nothing but a null graph. And so these are the possibilities of the graph. And other kind of graph what I'm going to discuss here is that multigraph. So multigraph means when a graph is going to maintain parallel edges, then I can able to say that should be multigraph. So whenever the graph is going to maintain a loops or parallel edges, then I can able to say that should be the pseudo graph. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.